say from 8, 9, 10, or whatever points we are taking, there should be no arc that should be cut beyond B double dash, because point B also cannot travel beyond B double dash. We will look at that. We will have this particular condition, that is second condition, that it should not go beyond B double dash in our 8th or 9th step. So we will have it. Okay, now with center equal to 1, radius equal to AB, that is my connecting rod, 375 mm. I'll cut an arc on A1, then I'll draw my connecting rod and mark my midpoint P1. This is for center 1. I have taken radius as AB and cut an arc here, so I'll mark it A1. Then I have joined this particular connecting rod and marked this center as P1. Now this is the first rod that we draw. I have de-highlighted it so that the figure does not become very complicated, because this particular figure is very complicated. The figure is complicated, the solution is very easy. Always remember, the more complicated the problem is, the more easy is the solution. So keep that in mind and go on with this problem step by step, and keep on following these particular steps. You won't have any complication in doing so. Next, with center is equal to 2, I'll cut an arc again on B, as you can see here, then mark it as A2, draw the connecting rod, mark this point as P2. Now with center is equal to 3, the same procedure has to be followed. Cut an arc with radius, keep the radius as same, A3, draw the connecting rod, mark the point as P3, and then move on. Now you can see here for the center 4, with center is equal to 4, I already have this point B, so I have highlighted this point to indicate that this particular arc has been cut from point 4, and this blue line indicates the connecting rod position from 4 to B, and this particular point P is its midpoint that we have already taken. Moving on, from this particular point 5, I have cut an arc at A5. I will join this connecting rod and then I will mark this as P5. Now again I'm mentioning one more thing, don't go on the dimension, don't think that these dimensions are wrong. These dimensions are not accurate. These are imaginative dimensions, or say I've tried to make it as accurate as possible, because I cannot in this particular PowerPoint presentation I cannot make these particular arcs very accurate. While you are doing the problem, you should make the lines, arcs and everything should be very accurately measured up till 0.1 mm. If you make a single mistake, say if you make a single mistake at A, then you will keep on enlarging that particular mistake, and by the time you reach to the final of the problem, that will be a mile long. Say it is a saying that if you start with a small mistake, you will end up with a mile long mistake. So you should not do that. You should keep this in mind. This is an illustrative animation, or say illustrative display. You should follow your scale and you should take the radius as required, as mentioned in the problem and as the figure says. Moving on with point 6, with center at 6, I'll cut an arc at A6, then I will join this particular connecting rod and take the midpoint and mark it as P6. Now why I am giving this points in series? See, once I want to draw the locus, once I have all the points and I want to draw the locus, I will have to follow the same path of the locus as the connecting rod did. So I'll know which point have to be connected. As we discussed in the previous lecture, that you in newspapers there are right since childhood we are connecting points and drawing figures and then coloring those figures. So this is very similar to that. That is a practice that was given since childhood. So now you can reap the fruits of it and draw the particular locus. Now for 7, again that arc will coincide at B double dash. As you can see, O to 7 is the crank, and from there AB. So I'll have my B double dash as my arc that is cut, and the center of this particular crank connecting rod will be, position of the connecting rod will be P7. So I have it marked. Now see, as I told you, we don't have to mark arcs beyond B double dash. So this particular step will make it clear that why I was saying that particular thing. Please refer to the figure. Yes, with center is equal to 8. If I take a connecting rod AB, I will not be able to reach B double dash, or if I am able to reach but B double dash, it will go beyond it, because already from point 7 I have cut an arc at B double dash. So it is not possible for to cut an arc from 8 on this particular curve. So now what will I do? I'll stop here. These particular points are moving from 1 to 9, that is from top to bottom on B dash to B double dash. Now what will I do? I'll stop going from top to bottom and I will reach the point 9, that is I'll take the lowermost point as 9 and then start marking arcs upwards from say B double dash to B dash. So this is how I'm going to do. So now now I'll start marking the arc upwards, and again we should remember that I should mark my arcs till my center reaches A dash or my arcs reach B dash. My center should not exceed A dash and my arcs should not exceed B dash. So first thing, with my center is equal to 9, I will cut an arc at A9, connect my connecting rod, and I will mark this particular point as 9. I have skipped 8 because we don't have 8. So from 9 I know, okay, after 7 I'll have to connect 9, because from now the points will keep on increasing from say 10, 11, 12, 13, 14. So but I should remember that from 7 I'm marking it as 9 and I have skipped 8 because it does not have its arc on this particular circle. So now it's done with 9. So I will move on with 8. Now this time 8 is possible. Why? Because I am marking an arc above, say going upwards, not going downwards. So at position 8 my arc will be this way. It is not that while coming down we don't have arc at A, but this particular crank, when this particular OA is at 8, the position of BQ is at A10. That is why the connecting rod 8 to A10 is there, and we have taken the point as P10, the center of the connecting rod, that is. Now we'll do it for same step will be repeated for 7. From 7 we will cut an arc at here A4 and we'll mark it as A11, draw the connecting rod and take its midpoint, and we have this as P11. As you can see, it is getting enlarged. I hope the figure is more clear than I think it is, but yes, you will be able to understand. Now next, with 6 as center, I've cut an arc at A12, as you can see, enlarged it, and then I'll draw my connecting rod, mark this point, and this is my P12, the center of the connecting rod from 6 to A12. Moving on from 5, this is my point 5, this arc shows point 5. From that I've cut an arc at A13, then drawn my connecting rod. This is my center of this particular crank position and I've marked it as A13. Now this is my 4th position. From 4th position I had this connecting rod, but this time I'm moving upwards. So I'll cut an arc at A14, draw my connecting rod, take the midpoint and mark it as P14. Now again from from 3 I will cut an arc at A15. Where is my cursor? Yeah, here it is. A15, draw my connecting rod. This is the point, its midpoint, and I will give it as P15. Moving on. Now this is the center 2. The center I've taken as 1. I've skipped 2 because it was becoming very complicated. So I've skipped 2. You should not skip 2. You should, from 3, after 3 you should take the center as 2, then 1, and then move on. So with center is equal to 1, I have cut an arc at A16, then taken this drawn my this connecting rod and taken my point as P16. So I have all the connecting rods. Now what do I want to do? I have all the arcs, I have all the positions. Now I will start drawing the locus. From where do I start drawing my locus? What was my first point that I drew? P from 1, that is P dash, then P1, then P2, then P3, then P4, then P5, then P6, then it will go on till P16. Look very carefully as the locus draws itself on the screen. From 1, 2, 3, 4, 5, 6, 7, and it will not have 8, so it will slowly go to 9, compensating for 8, then 10, 11, 12, 13, 14, 15, 16. Again it will take a curve. Now you can see that it is making an 8. But some of you will say, okay, after 7 when it is 9, why don't we draw a straight line? We should always draw a curve when we are connecting two distinct points in this particular condition. Say from this 7 my 9 was here, but I didn't connect it straight, I made a curve, because that particular connecting rod point does not drastically move from one point to another, it follows a particular curve. So I told before also, I have mentioned this particular point, that it should be a smooth curve. So I have tried to make it as smooth as possible, and you make it even smoother, that would give a better result, and I would be happier than I am right now. Okay, so it is clear that we have the required locus for this particular 4-bar chain mechanism, in which both the cranks OA and BQ are oscillating. We have gone very slowly in this problem. This is one of the most say complicated problems, but the solution is very simple. It's just that the figure gets complicated because you have to mark a lot of points in a confined space. So don't look at the figure and get afraid, oh what is this. When you start drawing it from a simple scratch, you make the you keep on drawing it step by step, in the end the problem does not look complicated. But if you look at a final stage of the problem without knowing the first step, yeah, then it will look complicated. But it is not complicated, it is very easy. So you can follow the particular steps to get this one final solution. Okay, thus we have the required locus. Let's move on to the next problem. Two more problems we are going to discuss. These problems are very easy, the next two problems are very easy, and we are going to discuss the second problem for today. And first of all, as I always say, and my favorite line is that let's discuss the question first. Let's discuss the question. Let's see. A rod 40 mm long rotates about r with a speed of 60 mm. It's just behind the 60 mm is mentioned just behind the video. So I'll repeat again. A rod 60 mm long rotates with the video is blocking the 60 mm thing. I'll just remove the video. A rod 40 mm long rotates about r with a speed of 60 mm. Now what does it say? 60 rpm, sorry, that is rpm, I made a mistake in typing. So a rod 40 mm long rotates about r with a speed of 60 rpm, that is 60 revolutions per minute. Now this is 40 mm is the length of that particular rod, and it is the speed is given. While Q moves along a straight line QR. Now figure one thing very straight. When you see the line animation, it will be very clear to you. There is a rod, say QP. Now that particular rod QP is rotating. That is one thing. Now while that particular rod is rotating, that particular point Q says, okay, Mr. P, you are rotating. Okay, I will also move in a straight line. I will not stay steady. Because you are rotating, I will start moving linearly. Where am I going to move? I am going to move towards R. The R is my other point, which is on right hand side. You will be able to visualize it even clearly. Let's see. I'll show you the line animation to make you visualize that. A rod whose center moves along a straight line. A rotating rod. So okay, this is Q, and say this is the rod which is rotating. Now this particular guy Q says, okay, I'm also going to move towards R. So this is the particular mechanism that we get. You can say that this is the particular locus which is followed by a point on the tires while the car is moving, but that would be even more complicated because it rotates at a higher speed. So this is the particular say animation of the figure that we are going to discuss, that we are discussing in this particular question. What other things are given? Now QR is given, the length of QR is given, and it is given as 108 mm per second. So 108 mm per second, sorry, it is a straight line, so its speed, the speed of Q is 108 mm per second. So we have the length of QR because we are going to discuss it for one revolution, so we have 108 mm. Draw the full scale path traced out by the end P for one complete revolution of the rod. Initial position is PQ along the rod. See, I'll show you the animation again, so to make it more clear. Look at the initial condition. Yeah, this is the initial condition, second, third, fourth, fifth. So QP was the initial condition, and the final condition will be R, and here it will come something like this, as you will be able to see in just a second. This is the final condition, so it comes back to the original slide. Okay, So how are we going to take the solution? The first thing that we do in these particular things where we have a straight line involved, or there is a path involved, we draw a straight line. So this is the first basic thing that you should do. You should draw a straight line. I hope it is visible on your screen. The next step, now we have drawn this line. Now we have to start from somewhere. So we will take a point Q. I've taken a point Q on this particular reference line that I have drawn. Now this particular point Q is the one who will be moving along the straight line towards, from say left to right on your screen, and there will be a rod which will be rotating about this point Q. Now its center is equal to Q and radius is equal to QR. I will cut an arc on this particular reference line and mark this particular point as R. So I have my QR. Now this particular point Q will be starting from the Q and moving from R. Say from this is Q is Vadodara and R is Ahmedabad. So Q will start moving from Vadodara to Ahmedabad. Okay, now I'll join QR. This is the path that will be followed by Q. Say you can say that this is the locus of point Q. Okay, the next step, with radius is equal to PQ. Now PQ is 40 mm, that is the rod which will be rotating is 40 mm. So with radius is equal to 40 mm, that is PQ, and I'll draw a circle with center Q like this. Now what is this? Now if we think that QP is just rotating and the center Q is static, this is the particular path that will be followed by point P. So this is, say we can say that this is the locus of point P in the condition where Q is static. Now when Q is moving, we have to find the locus of that particular point only. So you will be able to make out the difference that when Q is static, this particular circle is its locus, the point P is locus, and when Q starts moving, the whole scenario changes and we have to do a hell lot of work to find the particular locus, but it is very easy. The next step, I will join my this particular point and mark it as P. Okay, now as we did in the previous problems that was discussed in the last session, now I'll divide this particular circle into 12 parts. Why I'm doing this? I'm doing this because I want different positions of P, and according to that I'll find different positions of the point P. So I'll divide this in P1, P2, P3, P4, P5, P6, P7, P8, P9, P10 and P11.